The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon. It's Mark from SolidCAM. Today's SolidCAM Live, half-hour free training session. With me, as always, is one-man SolidCAM, Kevin Rankle. How you doing, Kevin?
Doing good. Thanks, guys, for joining.
Okay, so we had a question right at the last second of the last session, and luckily we saved the question. So the question is work holding with vices and over multiple coordinate systems as well. So basically, kind of like we talked about earlier this week, you've got a side one, side two. How do you actually bring in your vice, set it up, and then how do you get it set up for the side two as well? Let's say on a part like this, it's the top and the bottom. So first, how do you bring in a vice? How do you set it up? This aspect of the software is mainly from SolidWorks. It's more of an assembly inside SolidWorks thing, but when you work inside SolidCAM external, you'll notice that up in the top left here, you have a feature manager icon just like you would inside SolidWorks. So basically what we're doing here is SolidWorks Assembly functionality. If I click on this guy, we can see in our SolidCAM external, we have the design model, kind of like we talked about earlier this week. This is the solid you bring in on the front end of your SolidCAM. So you open up a SolidWorks part, go to Tools, SolidCAM New, or you go to the side menu, and you click on New. However you get into your SolidCAM, the model that comes in the front end is the one that's going to be associative. That's the one that if there's any rev changes, your copy of it will get updated to match the revision version that you're on the design side of things. So that is the fully associated part. Everything else inside of SolidCAM external is either this CAM solid here, which if we expand it is really nothing, or it's something else you bring in addition to those two solids. The CAM solid is really not a solid. It's just a placeholder for anything else you want to add, maybe sketches, surfaces, anything to help you program your part. But the reason it's a separate thing than the design model is because that's no longer associative. Anything you bring in once you've created your SolidCAM file is not associative. It just operates just like a regular SolidWorks assembly import. And that's what you're going to do with your subassembly that represents your vice. Now, if you've seen a lot of the KevCam videos on this topic, Kevin usually shows you how to get to different websites where you can download a model of your vice, your work holding, your clamps, whatever it is. I know Kevin's got his favorite one. I can't remember what mine is. I haven't pulled these models from the web in a while, but it's probably the same as Kevin's. But anywhere you get your work holding, your vices, your clamps, generally those companies will have their own solid models, or there's the one, I think, Kevin, the one you go to is what, 3D Connection or something like that?
3D Connection is one that is run by SolidWorks, or 3D Content Central is run by SolidWorks, or you can go to GrabCAD and download them from there too.
Yes. Yes. Now, whichever source you get it from, you might have to do some post work on it. Post as in like it's already been modeled for you, but you might have to reassemble it or set some new mates or something like that for it to be a little easier to work with. There's ways to deal with those solids when you bring them in, but that's a lot more of a SolidWorks functionality. So if you have trouble with that, as always, give us a call at the main tech line and we can help you with setting those up. But let's say we have a solid assembly that's already set up like I have. I'll just go to Insert Components. And again, this is all SolidWorks. I'm just going to browse to where I keep that vice. So in this case, I have a vice assembly, a SolidWorks assembly on my desktop. Click Open, and now it's attached to my mouse. It's waiting for me to place it somewhere on screen. I'm just going to place it somewhere away from my target. And of course, it didn't come in. Interesting. That is because I saved the assembly, but I probably did not save the solids, right?
Yeah.
So, all right, let's get rid of this. And off screen, the hidden magic of SolidCAM Live, I'm going to actually search for that same assembly and probably get us the proper one. But what I'm doing is I'm basically bringing in a SolidWorks assembly. So assembly inside of our otherwise assembly here. And basically all we're doing is we're going to mate it to our target. You'll notice in the left menu there, right next to the design model, there's a little F in brackets. That means that this solid, our target solid here, is stuck in space. It actually doesn't move. And if I try and move it, it says the component is fixed. That's because inside SolidWorks assemblies, either you have a fixed solid that everything gets referenced to, or it's floating and you have to give it some mates to lock it in place.
And while Mark's finding that, this kind of brings up a good point too. When you guys start a new SolidCAM project, now if you are running in external SolidCAM, it will automatically bring you into an assembly level. But if you start off with an internal project, the SolidCAM is going to stay internal, and it's still going to be a SLD PRT file at that point. So you wouldn't be able to insert in an assembly. So sometimes that does get a little confusing for some of the newer guys that once they start a new CAM project, it automatically puts it into an assembly level, so you can add these components in like what Mark is doing here.
That is a really good point to bring up, because internal versus external, that is the main difference. Either you're still inside of your single SolidWorks part file, or you're opening up external, which opens up an assembly. So you get different abilities depending on which one you're doing. Okay, so here is my assembly. Hopefully this guy comes in correctly now. There it is. Okay, perfect. So I usually recommend to just put it somewhere out in space, because we're going to mate this with our target. So I don't want it to be in the way while I'm trying to choose faces to mate it with. And depending on the model that you get from whoever you get it from, you either have to dissolve it so that you have the ability to move things around, or with this one, I should be able to right click and click on Make Flexible. Because if I don't do that, then it imports with whatever internal mates are already there, meaning that if I try and move that, it doesn't close the jaws, it just kind of keeps them in place. But if I right click on this and say Make Flexible, then all those internal mates should allow me to close the jaws. And
now,
we'll see that once it actually does that, but I guess not.
If you go down to jaw base, see how right there, you'll see how there's an F by that. Right now, that means that part is fixed. So if Mark just right clicks on that and does float, then we will be able to move everything around like we're looking for. Maybe.
Well, I'd have to be inside the assembly to do that. So now that I'm inside the assembly, it's fixed in space. Now I should be able to, let's do that again. Let's make that float, all the configurations, and then now it floats. Okay, perfect. So let's get out of there. And let's go and mate this. So let me just close these up. So mating inside SolidWorks is literally just adding a relationship between the solids. A SolidWorks assembly is just a collection of associations between different solids. That's why when I brought in just that one assembly, it said it was empty, because I didn't actually bring in any solids. I just brought in those relationships. When you do it properly, you have a bunch of solids here where you can give relationships to. So let's say, for instance, this will be our top face. So I probably want to have it sitting in the vise. Let's see, is there a bottom? There's no bottom edge there. So what we'll do, or there's no parallels in there either, it didn't come in. So what I'll do is I'll do a distance mate of, let's say, 250. Let's say we're holding the bottom 250 of that part. So from the top face of the vise to the bottom face of the part, that will be 250, but it's in the wrong direction. So I'll just do a flip dimension, and now you can see that it'll hold it by 250. So that locks it in the Z direction. This guy still floats, he still moves around, but it always stays 250 below the face there. So now we have to line this up a little bit better. So I probably want to hold it.
And one thing that I like to do is get my assembly somewhat close of where you want things. That makes it a little bit easier when you're going through and picking your operations, or your mates, sorry.
Yeah, no, exactly, because a lot of the times you probably don't really know how it's going to line up. Like having it this close, I know it's going to line up exactly like I like right there. But like Kevin said, if I had this off in space, it probably could have actually been like it wants to, like I'm telling it to do here, but maybe facing the other direction completely. Now that's not necessarily a bad thing, because you have all these other options over here to flip it back and forth if you need to. Sometimes it's a good idea to have it close, so you actually know, you can kind of expect where this thing is going to line up. So what I've actually done here is I've used in the advanced mates the width option. And what width does is it takes the two surfaces that I selected to start, and it sandwiches the other two surfaces between them. So it actually gives it an equal distance there. Now, in reality, I probably would want these jaws to close in, but again, this assembly, there's probably something wrong with it. I'll probably want to go in there and adjust the internal mates so that it actually allows the jaws to close on the part. But for today's example, this is probably going to do. It's just showing you that I can do a mate in between those two faces there. So I'll just click the green check mark. And now in the Y direction, it's locked in between those two faces. If I don't do anything else, this guy still moves, but it only now slides in the X direction. So I need to actually lock this into the X direction. I'm still going to use the width mate, because even though I'm not closing in on faces, I still want this thing to be centered. So what I'll do is this. I'll say between this face and this face, I want to sandwich that face and that face. And what that does is it lines them up. So now that is equal distance from each one of those faces. That is sandwiched in there. We'll exit out of the mates. And I mentioned before that the F means that it's fixed in space. It can't move. Well, the vice is now also fixed in space because I can grab it, and when I try and move it, it says it's fully defined, meaning that it has mates relating to a fixed solid. So it itself is not fixed, but because I've added all those relationships, it is fixed in space to something that is fixed in space.
And I think that goes to answer your question, Jake, that everything's already pre-mated with those, so they won't be floating off into space. So the jaws they're not fixed, they're just mated.
Correct, yeah. I would always say you never want anything in here to be anchored or stationary unless it itself is something that doesn't really matter where it is in space. Like for instance, my target solid is what I brought in inside SolidCAM. So I kind of don't want that to be floating in space. I want that to stay relative to wherever I put my Mac position. But since this guy's anchored in space, I want everything relative to that. And you can skip a lot of this if you want to just get going. The drawback of that, though, is if you do a misclick and you shift something, any definition relating to the locations of these solids will be disrupted. So your toolpaths will probably want to recalculate, or your fixture definitions will want to be recalculated. You'll break some sort of associativity when you shift the part. So it's always a good idea to make sure everything's locked in place, either anchored with the F or anchored by mating it to something that already has the F. But basically, I have my side one fixturing set up. So what I'll do is I'll go into my setup for my Mac 1. I can go into my fixture. I'll click on the three dots. One question I usually get is, what's the difference between doing it here and doing it over here under fixtures? If I just click on define fixture. When you define fixture, you're just assigning the solid as the fixture. You're not really assigning it to use it. You're not really assigning it to a coordinate system. But when you do it inside setup, if you go over here and click on these three dots, it brings you to the same window. So you're still assigning the solid as a fixture, but then once you click this green check mark here, it assigns it to that coordinate system. So you're actually kind of going into the same road you have to anyway without having to go back and forth between different menus. So I've got this entire assembly on here. I can go and click the individual solids if I want to, or I can make it really simple and just say Cad Selection. And then again, use some SolidWorks functionality to our benefit. What I mean by that is if I come to my feature tree as it sits over here, I can now click on the entire assembly. So every solid in that assembly, the bolts, the slider, if there's parallels in there, everything that's part of this assembly will now be assigned as my fixture. There you go. So there's really only three solids there, but that collects everything. This is very useful if you've already done all the mating on, let's say, your tombstone. You've got vices all over the place. You've got all kinds of different stocks and solids and all that kind of stuff. If you could do a CAD selection, it's a lot easier than trying to click on something that's maybe hidden or maybe inside of another solid, whatever you're trying to select.
Yeah, like when you guys use the Kurt Vice from 3D Content Central or GrabCAD, there'll be about 12 different components in there. So
now you don't have to assign every single one as a fixture. I mean, there's some components in there that are never going to collide with your toolpath, but you can include them for, display purposes. If you're trying to show how this thing should be sitting on the table, where the components are, whatever it is. But you don't always have to select everything. For instance, here, I probably wouldn't even bother with the base. I probably would just go with the two jaws because that's the only thing that's actually going to be colliding with my toolpath. So when you set up your fixture, you choose your solids, and now you can go to Fixture Mounting Coordinate System. And the coordinate system you're assigning here is not a MAC position. It's just simply a reference point for how this thing is going to sit on your machine. And to make it really simple, you've got the same functionality here. I'm just going to set this as top center of model box, choose the bottom face, and then just flip it around. So you can see now the Z is facing the wrong direction. I'll just do a flip around X so that Z is pointing up, and I'll get the X to point in the same direction as MAC 1 position 1. So basically I'm just telling it that as this thing sits on the table, that's the reference point for when I want to shift it around. So if you have a machine sim, this is a really easy way to place the vise right on the table. You don't even have to figure out coordinates or anything like that. I'm going to get that to line up with the machine 0 just by saying the bottom center of the part is where I want that to sit on machine 0. Now, if it should be sitting a little higher up, or maybe whatever model you've selected is not the base of your vise, once you get to the machine setup window, you have that X, Y, Z coordinate to play with. And we're going to see that in a second here. Let me just finish up with the part mounting coordinate system. The part mounting coordinate system is basically MAC 1 position 1, but you're going to reset it up here because this is a coordinate system that is relative to the fixture coordinate system. So I'm just going to set this up as top corner model box, very similar to what I had from a MAC 1. So there it is. Now, if it didn't pop up in the same location, like we saw earlier this week, I have all these options over here to shift it around. But that is just the part mounting coordinate system relative to the fixture mounting coordinate system, and the fixture mounting coordinate system is relative to your table 0. To see that, once you get back to the machine setup screen, there it is. So my part is sitting relative to the fixture coordinate system. If it's sitting on the table maybe a little higher up, then in this window here, I'll make it maybe a little higher up. Let's make it 2 inches. Actually, that's the wrong one. That is the part mounting coordinate system. Let's go to here. Let's make this 2 inches. So now the base of the vise is sitting 2 inches above the table.
And this
Does that make sense?
Yeah, and this is basically used just for the machine sim. If you guys are running that.
For the machine sim, but also sometimes for 5-axis, because if your post doesn't have, what's it called, dynamic work offsets,
yep.
then you need to plug this in so that your machine knows the pivot points of your 5-axis. So now we got this all set up. This is for MAC 1 position 1. Now let's talk about MAC 2. Well, first, let's add a MAC 2. We'll just say add. So we'll just make this MAC 2. And we'll do top corner, but on the back side, wherever it ends up being. So something like that. So there's our MAC 2. So I can do operations on the back side. I can do all the operations, but I still have this vise on screen, and I need the vise for the other side as well. Let's exit out of here. Okay, so let's do side 2. Well, I want that vise. So what I'll do is, again, use some SolidWorks functionality. I'll hold the control key on my keyboard, grab that vise assembly, and just make a copy of it. So now I have a copy that's independent of the other one. I can move that around because it's also floating, and I can just mate it to the other one. Now, I've got them both on screen. That's going to be kind of weird when I have them mated to the same part. They're going to be on top of each other. So in that case, we can use display states. And I believe we talked about this. Did we talk about this week?
Yep.
I know I trained somebody on this week.
Yeah, I remember we did talk a little bit, I think it was last week, actually.
Okay, last week. So what basically display states is I can add a display state by right-clicking and saying add display state. I'll call this one side 2, and I'll relabel the first one.
I think
double click on it.
You may have to, it's just like configurations.
Yeah, maybe just hit F2 on the keyboard. There it is. Okay. Side 1. So side 1, we don't want to see the side 2 vise. So what I'll do is I'll right click on it and I will hide it. So it's still in the tree. It still goes towards my assemblies, my fixture definition. But if I hide it, I don't get to click on it. That's the only thing hiding does. If you suppress it, then you're actually removing it from any kind of definition, and that could really disrupt your setup. So there's our side 1. Let's go back to side 2, and we'll hide the side 1 vise by doing the same thing. There we go. So now I can mate that to my part. I can set that up with another machine setup. So if I say machine setup at the end of the tree, I can set this one up for MAC 2. And I'm not going to mate it to the solid, but I just want to shortcut this real quick. We'll go fixture. We can assign a new fixture. And again, I'll just do Cad Selection and grab the one that's on screen, resume. And I'm going to skip over those as well because we've already covered that. But now I have a fixture for side 2. So with the display states, if I want to get that out of the way, I don't have to do anything other than just double click to go back to that one.
Yeah, and this makes it real easy going back and forth between an op1, op2, especially if you guys are just running with one vice in the machine, to be able to switch back and forth very easily. When you start going through and programming, that's the whole intent of setting up that display state, so you get that one vice out of the way, because if Mark would have mounted up this one or made it up this one right here, we'd be showing vices over vices.
Yeah, and it can get a lot more complex when it's not just side 1, side 2, but it's multiple setups. Then you've got vices on top of vices on top of vices, and things can get in the way. There's different configurations, that sort of thing. And to answer, I don't know if it's a question or if it's a comment, but Edwin says he mirrors the fixture. You can do that as well. But a lot of the times inside SolidWorks, when you do something like a mirror or a translate or a pattern, like you see up here, it might carry those mates with it. So it might not necessarily be floating. It might actually just be a mirror, but it's still locked into the same position. So a lot of the times I'll do a separate solid because then I can do individual mates. And the idea of mirroring it works for when it's just the side 1, side 2. But that's not going to work when you have to flip the part 90 degrees or give it a different setup completely. There's different solids. So this overall is a procedure when you bring in your vise, your clamps, your work holding, and you mate them however they need to be mated. But one option, one quick, simple option is to mirror it, because it literally is just a side 1, side 2. So you could mirror it, but then there are some limitations with that. Okay, so we have our setup for side 1, setup for side 2. I could mate that, but we'll skip over that. And that's pretty much it. The only thing here is all the operations under the first setup are under Mac 1. All the operations under the second setup are Mac 2. But I probably don't want to post those all in the same code because obviously if it's side 1, side 2, I want to have the chance to take it out, flip it around, and put it back in the vise. So what you can do is at the end of those operations, let's just add something real quick here to just get something on screen. So we'll just do auto updated stock. I'll just add a quick face mill. Toolpath is empty. All right, well, either way. So there's a toolpath on screen now. Now, rather than going right from G54 to G55 or setup 1, setup 2, what I can do is I can add what's called a split. And the split is just like it looks like in that little graphic there. It actually splits everything before the split and everything after the split into 2 separate G-code files. That way I don't have to worry about accidentally posting stuff from side 2 while I'm posting side 1. You can let the software just figure that out for you by leaving that split in there.
And with a lot of the newer post processors, if you don't have that split in there, it should still come out in 2 different G codes. But if it doesn't, like I said, this is more post processor dependent. If you guys have 2 setups in there and it's not producing out into 2 separate G code files, then you can add that split in there too.
Yeah, there's a lot of extra functionality in the post now. This is kind of an older way to do it, but this is, I find a lot of our customers, they either don't do this or they don't think about this aspect when they do multiple setups. So I usually show the split, and if the split's not necessary, then you just eliminate it.
Yeah.
Okay, so we're near the end. Let's see, no new questions. Actually, wait, here's another question. So the question is, when you mate from side 1 to side 2, does it disrupt the associativity from side 1? No, because what you're doing is you're just adding additional solids on top of the only solid that's associative, and that's the target. So really, the benefit of doing side 1, side 2 in this one CAM part file is that you're actually working off that same updated stock, but the associativity is not disrupted. You're basically working off the same stock and the same target. So adding additional solids doesn't really disrupt anything. It's only to your benefit to set it up this way, because then you can actually reuse that same stock. So the other way to do this is saving that STL we talked about yesterday. You'd have to save the STL and load it in another CAM part file to get that same functionality, that same associativity. But if you do all your setups in the same CAM part file, then you don't have to do that. That STL is already being saved for you in the background. The only time you have to do the STL option is when you're changing the post. So if we're working under the same machine and we're literally just changing the offsets, then you can just add as many Mac positions as you need, as you have, and then you can just keep setting up vices and clamps and that sort of thing. One other trick, I guess, associated with this kind of is some people, they don't even have to, they don't like to set up G54 and G55 or P1, E1, whatever it is. They want everything to be under 54. Well, again, this is kind of an old post, new post kind of thing, but you always have the ability to relabel this as whatever you like. So if I wanted everything to be 54, then I can label each one of these as 54. And then in the newer posts, it'll automatically make every Mac inside this CAM part file G54. If you have an older post, then you want to go to your CAM part. And then on the bottom here where it says I work offset method, instead of a 0, change that to a 1. Basically meaning you're turning that option on. And that option reads from the renamed Mac rather than just the default. So Mac 1 was always going to be G54, Mac 2 was always going to be G55 on this machine, but as soon as I change that to a 1, it actually means that it's going to look for that rename. So my Mac 2 will now output as G54.
And to kind of go with Scott's question, when you switch from side to side too, you know, the biggest thing to remember when you guys are adding multiple fixtures like this is don't suppress, just hide. That way, if you suppress, then it actually will hide the vices and suppress all the mates that go along with it, which can get you in trouble if you start getting quite a few in there. Where like what Mark was showing us with the display state and hiding it, it's just a visual only. So it's not removing mates or anything like that. It's just hiding and showing is all it's doing.
Okay, and Edwin's question, he saw that there's another option down there called I number of fixtures. So the I number of fixtures actually goes along kind of with this. So let's say you had multiple vices, multiple setups on a single table. This is kind of an old function, but what you can do is you can actually output all the operations you put under Mac 1 to all the other Macs that are on your table. So let's say if I had all 4 on this HOS, I had 54, 55, 56, 57. If I set this to a 4, then from this one CAM part file under Mac 1, G54, in the G code, it'll actually output for 54, 55, 56, and 57. So the reason I say this is old is because we actually have a new function that we can use called transform. In transform, now it's new, it's not that new. I think it's they introduced this probably, when do you think, Kevin? Was this like 2016, 2017?
Yeah, somewhere in there.
It's not that new anymore, but a lot of people don't see this, but it basically works almost the exact same way. I can transform my operations across Macs. So this toolpath was already under Mac 1. I can tell it now to also output under Mac 2. So whatever offsets you have on the machine, you can output to them. But the I number of fixtures is basically this, but for the entire CAM part file. Whereas with the transform, I can pick and choose which ones I want to transform. Does that make sense?
We don't get any questions on it.
Yeah.
Yep.
Okay. Perfect.
Okay, perfect.
So basically, that's all that is. But yeah.
Yeah, it makes it a lot easier. Like Mark's saying, you got 5 vices on the table, and you want to run 5 identical parts. There's no reason to have to program that part 5 different times. So we can just switch it over to I number of fixtures. Tell it we will have 5 fixtures on there, and then you just have to program that part 1 time. The only thing that you will not see is by doing that in the simulation, it's still just going to show you simulating the 1 part in there.
Correct. Yes. The I number of fixtures is only in the G code, not in the simulation. Whereas the transform coordinate system, you can see that. If you have it all set up inside, you have to set up the coordinate systems inside this part file anyway. So you'll see it in your simulation. If you set up multiple stocks, multiple targets, and all that, you can actually see the material being removed. But Pierce has a question. So is there a way to do the coordinate system offsets for all operations in one setup? Is there a way to do the coordinate system offsets for all operations? I'm not sure if I understand the question. So you mean like in one? not having to click multiple times. There is a way to set up multiple coordinate systems. You can use transform here as well. You have the ability to do a translate of all your coordinate systems. You can get all those coordinate systems in one click, and then when you do your coordinate system transform, you're just basically just checking them off, in the list, like so. You'd have them all listed here, and you just do check all, and then you can transform it across all the coordinate systems.
And those coordinate systems don't have to be in line with anything at all. So when Mark showed the transform of those coordinate systems, they could be off in la-la land. It really doesn't matter, because when you guys go to run this on your machine, you guys are finding your G54, G55, and G56.
Exactly. Yeah. You can do it visually inside the software, but on the machine, you're actually setting up those individual offsets. So, Pierce, does that answer your question? I'm not sure if we're getting your question. Okay. Yeah, I think that's probably what the question was. Okay. So, so all the operations at once. Okay. So his basic follow-up is so if he has 10 operations in one setup, I'd have to set up a coordinate system for each one. Is there a way to do it with one click? If you have 10 parts and they have each of the 10 parts has its own coordinate system, then you don't necessarily have to do, well, like Kevin just said, you can set up a whole bunch of them here. Let me do this real quick. So let's say we have our Mac 1, and I want to do a transform of that for the 10 parts. So I'll go translate, matrix, and let's say we've got 5 of them in X that are spaced, just do 5 inches each, and then we've got 2 in the Y direction, and we'll say that those are maybe 10 inches apart. So there's 10 parts right there. If those 10 parts each have their own coordinate system, then I've just created that with the coordinate system transform. And in time, it's just going to pop up on screen. But let's see here. So not coordinate system, but operations profile. So not coordinate systems, but operations. Well, that's the same thing. There's the transform command for the operations as well. So let's say we've got these 10 parts. Now, forget about the coordinate systems, but let's say we had the 10 parts. I can do a transform of the operation itself, and if we know how far apart they are, we can use translate. So again, let's use that same example. So we've got 5 of them that are 5 inches apart, and then the second row that is 10 inches away. So now I've repeated that toolpath 10 times. Now there's nothing there because the toolpath didn't calculate properly, but let's get something on screen here. Oh, I don't have a stock definition, so that's why that guy didn't work. So let's say we choose this top face.
You had to click model or define first.
Define, yeah, I gotta do define. So face milling operation is a little different because you have to choose your type and then choose define. But let's say we got that. And then levels will just go from top of target down to bottom of target, top of target, whatever. There it is, okay. And you can see that from the transform, it did all 10 parts. It did the face mill of all 10 parts in one click. So all 10 parts under same coordinate system, same operation, but I just gave it a transform. All right, so let me get back on the list here of questions. So hopefully, I think that's what Brian was just talking about. Maybe he transformed set as many operations at once. I think that's what Brian was getting at as well. But the follow-up from Pierce, I have 10 different operations and 10 setups. Then I need to apply each transform 3 times for each operation. Is there a way? So basically, if you had a bunch of operations, let's go to a part that actually has a lot of operations. So it's basically this part that I use in demos. It has the splice already applied. It has the stock and the target. It already has some operations. If I have 10 setups of this, if they each have their own coordinate system, then I can use the coordinate system transform. If I have them on my table and I actually set them to be exactly a certain distance apart, then I can just do it under one Mac position. And of course, for today, these guys would not be calculated. So let's just recalculate these. And we're going a little overtime, but it's Friday, so hopefully you guys got some time. Okay, so let's recalculate some of these. Okay, so multiple toolpaths. I'll take all these toolpaths, and to do it across my 10 parts, I'll click on Transform, Translate. We'll do it as a matrix, and we'll do the same thing we had before. This time I'll just do fewer of them. I'll just do 3, spacing of 10, and let's just say that's it. We'll just do 10 parts. So all those operations have now been copied. So 3 parts done exactly the same way. Now, if they're 3 different parts, then you're not copying toolpaths. You have to reselect geometry when it's different.
Okay, looks like that's exactly what I was looking for.
Okay, okay. So there is a way to transform, copy, repeat your toolpaths in many different ways. It just depends on your setup. If they're all equidistant, I just literally got off the phone in a training session where the customer had a base plate where he actually set up the positions of each of his individual parts, so he knows for sure that they will be 10 inches apart. In that case, you can use Translate. You set up one offset and you just say that it's 10 inches apart. If they're different locations and you're using coordinate systems, then you can just do a coordinate system transform. And in this case, you don't even have to know what distance they're apart, kind of like what Kevin just said. You can just kind of put the coordinate systems on screen wherever you like, and then if you want to actually see how this will come out, then you can actually add individual stocks, individual targets to represent that.
And Mark can go through and cherry pick what he wants. So kind of going with Pierce's question here, he was just doing one at a time and doing that, but Mark can go through and let's say there's a couple that he didn't want in there. He can go in there and just cherry pick the operations that he doesn't want to transform and do it that way as well.
Yep, absolutely. So let's say all 3 had the same face milling, but maybe there's some differences inside, but I need to do face milling, and then maybe they all have the same holes to be drilled. So I can click on those and that one, and like Kevin said, I'm cherry picking them. So I can do just those ones. And I can give it the same kind of setup here. In the same window, you don't have to just always do everything in X and Y. You can choose a different coordinate system completely and choose the directions from that one, or you can set up your own axes by choosing different points and getting different angles. If it's not exactly a repetition, maybe you have them set up certain distances apart, but not always the same distance. Well, every time you click on one of these, there's always a list option where you can type in coordinates. So let's say the first one is about 5 inches away, and then 2 inches up, and then nothing in Z. I can click enter. And then the next one happens to be 13 inches up, maybe nothing in Y, and nothing in Z. Then I can click enter. And you can see that it's showing me a preview of where those are going to line up. So not everything has to be a simple repetition. It could just be a copy of a certain distance away. Okay, so I think that's it for the questions. Yeah,
and
I guess.
And we do have more questions that did carry over from yesterday. So, and what we'll do is we'll carry those over into Mondays for everyone. So we'll get all the questions answered too.
Yes, and that leads me into talking about, yes, we are continuing this next week. I just got our internal guy to set things up. So it should be the same link, just extended until May 15th. But if you don't see that, again, you can always go to the website and make sure you got the US flag on the top there, and then just sign up for the webinar again. But we are continuing this every day until May 15th at 2 p.m. 2 p.m. Eastern time. I think May 15th, if we do it on May 15th, Kevin's probably doing it solo because I'm off on the 15th. So, but we'll see what the timing is like. But yes, we're continuing this next week. Sorry, Kevin, question?
The Canadians, they get all these good holidays that they get to take off from.
Yes. Well, not everyone can live in the best country in the world, but that's fine.
But yeah, we'll be all set up. So even when Mark's not here, we'll still continue on for the 15th. So.
And yes, Brad, if you'd like to have this one, I can send you this one as well. Anytime you guys want any of these part files, just let me know. I can send it to you. Anything you see in the videos on the YouTube channel or on the website, we can send you those as well. Yeah, so starting next week, It should be the same login, but if you're having any trouble, you can always email us. Let me give you my email, and we can get you signed up, or at least send you the link to sign yourselves up for the next training session while I type this out. If you have any questions, like Kevin said, we actually have some that we'll cover on Monday, but if you have any new questions, you can always send it to us using my email there. If you want to set up your own training session direct with me, Kevin, Greg, Paul, all the guys you've ever talked to when you call into tech support.
Greg,
Scott,
Greg.
Russ.
We only got 3
Greg
that work here.
Yeah, even guys we don't have. But no, you can talk to anybody in a training session. You just let me know, and I'll help you guys schedule that with your chosen training guy. If you know anyone that could benefit from using SolidCAM, just let them give them our contact info, or give us their contact info if they're okay with us calling them direct. And there is a finder's fee associated with that, so you can get a little bit of something from just being the word of mouth for SolidCAM. But other than that, we'll end the session now. We went a little over time, but I think it's free. Nobody cares. So we'll end the session now. Everybody stay safe. Keep your family safe, and we will talk to you on Monday.
All right. Thanks, guys. Have a great weekend.